All right, so up until now, we've been talking about something called one-step equations, okay? Today, we're going to be working on chapter 2.2, and today we're going to start working on two-step equations, okay? So we want to solve two-step equations. So solve two-step equations. What does it mean to solve something again? I know we've talked about this a couple of times, but what does it mean to solve something? Find an answer, okay? And what does it mean if we have something, or what does it mean if we have an equation as opposed to an expression? What does an equation always have? An equal sign, exactly. So, first thing I want to look at is what is order of operations? Does anyone remember that? What's order of operations? PEMDAS, okay? So remember when we do PEMDAS, it's P-E-M-D-A-S. Okay, P-E-M-D-A-S. What do these represent? What does P stand for? Yes. Parentheses. What does E stand for? Exponents. M and D is, Amber? Multiplication, division, and A and S is addition, subtraction. Okay? When you learned math, when you were in like elementary school, did you actually learn math in this order? No. How did you learn it? You learned it backwards basically, right? You learned how to add and subtract, then multiply and divide. Then you probably learned about exponents, and then parentheses is kind of like everything all together. So the same is going to be when we are undoing things, when we're solving, okay? So when you're solving, you want to undo the easiest thing. I just didn't spell easiest right, sorry. Easiest thing first. Okay, so when we are solving, you want to undo the easiest thing first. So let's look at something like, for example, 1. I would like you to solve, and all of your problems are going to be asking you to solve 4x minus 3 equals 13. 4x minus 3 equals 13. Go ahead and get that written down, and I'll come back to it in just a second. If you think you know how, go ahead, yeah, you can try to solve it. Oh. Have we seen equations like this before in other math classes? Probably, yeah. Okay, so we first want to, I said undo the easiest thing first. So what do you think would be your first step? Please. What do you think is the first thing you can undo? Any ideas? Okay, so solve means I'm going to get this x by itself. This x is attached to a 4 by what? By add, subtract, multiply, or divide? By multiplication. It's always attached. It's also attached to a 3 by subtraction. Which did you learn first? Which is easier? Multiplication or subtraction? Subtraction you learned first. Okay, it's easier. So we always want to undo that part first. So how would you undo a negative 3? You add 3, okay? This is using something called the additive inverse. Okay, so using additive inverse. Okay, I want you to think of this equal sign as kind of like a fence. Okay, so if this is a fence, if you do something to one side of the equal sign, you have to do the same thing to the other. Okay, so you have to be equal to both sides. So if we add 3 to one side, you add 3 to the other. So I got 4x equals 13 and 3 gives you what? 16. Then to undo what's attached to the x, how would I undo this multiplication of 4? Divide by 4. What's that called if I'm multiplying or dividing something? What am I using? Multiplicative inverse. Okay, so multiplicative inverse. If you divide both sides by 4, what happens? The x goes by itself, and x equals what? 16 divided by 4? 4. That's That's your answer that I'm looking for. X equals 4. So what I'd like you to do now, because this is pretty basic, I think you guys have done this before, is I want you to open up your books to page 122. Okay, let's open up our books to page 122. And I want to see if you can do the got it A and B. Okay, the got it A and B. Okay, so open up your books. Let's look at these two got it. Do we have it? Have you got it? Page 122. Okay, page 122. I want you to look at A and B. Yes, there's a cute little monkey on the page before. The page before. You can see it when you open up your book. So, got it, A and B on page 122. Once you think you have an answer, check it with your elbow partner or the person sitting right next to you. And then we'll go through them together. Yes, ma'am. Yes. So let's look at these got it. Page 122, A and B. Let's try to get those done. No. Not me. But thanks. Okay, so let's get these done because I'm going to call on someone in just a second for an answer. And it's probably going to be someone whose name starts with F.
You said S or F?
F as in Fabian.
What? Can I try my pencil?
Yes. Jeremy's going to let you. Just FYI. Okay, so I want to see your eyes as soon as you think you've gotten A and B, please. Dustin, are you done? A and B. It's on the other side. You didn't even start yet. So.
What'd you do with C and D?
A and B. Oh, good. I was just asking if you were done. Lots more coffee. Lots more coffee. Kylie, you're not coffee. Okay, so for A, do you think you have the answer, Asia? Keep going. That was a scared look. Do you think you have the answer, Jasmal? 2? A, you got 2.
No, I got 6.
You got 6. Okay, do we agree or disagree? We agree, okay. Oh, did someone disagree? Oh, Court's just stretching, okay. That's okay. So, first, we should start by subtracting 2. If you subtract 2 to both sides, you should get 3x equals 20 minus 2 is 18. Then to get rid of the 3, you divide it away. And we should get x equals 6. So, yes, x equals 6. Looks good to me. Okay, how about B? What do we think we got for B? Or what answer did you get for B? Fabian.
I didn't do that one.
Oh, let's do it together. What do you think is the first thing you should do?
Subtract 5.
Okay, so subtract 5 from both sides. That gives you 2n equals, what's negative 1 minus 5? Negative 6. Okay, then divide both sides by 2. If you divide both sides by 2, what do we got for an answer? N equals, say it again, louder. Negative 3. There you go. Good job. Okay, n equals negative 3. Anyone have any questions on how we do this type of problem? Okay, these are ones that I think you probably have done before. I hope that you've probably done before. Yes, these look familiar. Please nod your heads. Yes, thank you. Okay, let's try another one. So now that we've got that concept, let's look at another one. Okay, for number 2 in our notes, I would like you to solve 27 equals 1/3 n plus 2. 27 equals 1/3 n plus 2. I kind of apologize that we're using so many different variables, but your book, hardly ever uses x. So if it was up to me, we would just always use x. But your book and the testing that you're going to do this year likes to use all kinds of different variables. It really doesn't matter, but I would just prefer if they would use one variable, but that's okay. I didn't write the book. I know. Makes me sad, but that's okay. So, where do you think we begin? What do you think is that first step? Giselle. Perfect. Subtract 2. Okay, so subtract 2 from both sides. Subtracting 2 is called using the additive inverse. So anytime we add or subtract, it's called using the additive inverse. Okay, does anyone know what does the word inverse mean? Say it again. Kind of like reverse. Yeah, additive inverse basically means do the opposite of the addition. Okay, so subtraction. Okay, so additive inverse. So if we subtract 2 from both sides, these go away. 27 minus 2 gives you 25 equals 1/3 n. Then how do we get rid of a fraction? We use, what is it called, Rihanna? Multiplicative inverse. Yes, good job. Way to use that vocabulary, okay? So we're going to use the multiplicative inverse. That's a very long word. Use the multiplicative inverse. And what is the multiplicative inverse of 1/3? 3/1. Okay? 3/1. Now, does it really matter that we put the 1 on the bottom? Not really, okay, because it goes away. But it just helps us to feel like we're complete. It's just the way we're used to seeing things. So I'll continue to write it that way. So 3 times 25 gives you what?
75.
75. And do I need to write over 1?
No.
Not really. But this is correct, that n equals 75. Does it matter, by the way, if your variable is on the left side or the right side of the equal sign? Does not matter. Okay, a lot of people get a little confused by that, but it absolutely does not matter. For number 3, I would like, we're going to go back to some got it's. Okay, we'll come back to 3. Okay, now I want you to look on page 123, and let's look at C and D, involving some fractions. Okay, let's look at the got it on page 123. I want you to look at C and D, please. C and D up at the top of your page. I want you to look at these. Hopefully we've got this, and then we will move on. My room is straight. Thank you. 668. All right, so for C, what did we get for an answer? Isabella. What do we get for an answer, Isabella?
I got
Negative what? 16. 1 6? Okay, negative 16. Did anyone get the same answer? Do we agree or disagree? Disagree? Okay, let's work it out. Isabella, what is the first thing that you did here? Right, you subtract 9. Okay, if you subtract 9, oh, I see what you did. What's negative 1 minus 9?
10.
Negative 10. You subtracted the numbers, and you really have to, if it's the same signs, you add them, keep the sign. So negative 10 equals 1/2 A. Okay, what's the next step I should take there, Amber? Okay, so multiply both sides by what? Not negative 2, but by just 2 over 1. Okay? If it's the negative is attached to the variable, then you multiply by negative. But this one, you're just going to multiply by 2 over 1. Then if you multiply 2 times negative 10, what do we get for an answer? A equals negative 20. Okay? Do we agree with negative 20? Hopefully, yeah. Okay, what do we get for an answer for D? Ashley, what'd you get for an answer for D? 5 over 24? Is that what you said? 5 over 24. Did anyone get the same answer? Let's check it. Okay, what's the first thing you did, Ashley? You add 5, right? So add 5. You guys are so quiet today. We get 2 over 5R equals 7 plus 5 is 12. Then what did you multiply by, Ashley? The reciprocal of, which is what? 5 over 2. Yeah, sounds good to me. Okay, if we multiply both sides by 5 over 2, okay, the 12 and the 2 reduce to give you a 1 and a 6. And then what do you do with the 6 and 5? Multiply them, so R should equal what? 6 times 5? 30. So you made a mistake somewhere. I'm not sure where because you just told me how to do it right. So, yes, R equals 30. Yes, ma'am.
If we did it sort of a different way, where we did 5 times 12 equals 60 and then reduce.
Yes, that is totally fine. If you did not cross reduce, you would have ended up with 60 over 2. And as long as you reduce at the end, you will still get the same answer. Yeah. So if you don't see, and sometimes like you might not notice that you could cross reduce. As long as you reduce your answer, that's totally fine. Totally fine. Okay, let's look on to the next type of question. Okay, I don't know why I erased this just a minute ago. But the next type of question is example number 3. And I would like you to solve 5 minus 7x equals 61. 5 minus 7x equals 61. 5 minus 7x equals 61. So we're going to be solving the exact same type of way. What is the first step you believe that I should take? Anissa?
You would add the 5.
Very close. Is the 5 positive or negative right now? Right now it's positive. So to get rid of it, you have to subtract it. So we're actually going to subtract a 5 from both sides. If you subtract 5 from both sides, what does that give you? Negative 7x equals what? What's 61 minus 5? 56. Okay. Then when we divide both sides, or I'm sorry, what should you do to get rid of the negative 7? Divide by what? Negative 7. Okay, you do want to divide by the negative. Then we should get x equals, what's 56 divided by negative 7? Negative 8. Okay, negative 8 is the answer that I'm looking for. Okay, notice how most of these are going to come out nice numbers. You're not going to get too many weird fractions here. Okay, now let's go back to our books and look at page 123, and I want you to try the got it, E, F, and G. E, F, and G. Okay, so these are going to involve couple fractions, but I think that you've got it. E, F, and G, please. I'm sorry? Well, give it a shot. Okay, E, F, and G. I want you to try these 3, please. Nathan's right. G looks a little bit tougher than what we've been doing, but I think that you can figure it out. Oh, you figured it out. Okay, well then never mind. Don't know what I'm talking about. almost done. I see some sleepy eyes. I'm aware. Timmy's still gone? He's never been here. Okay, so what's the first step you think I should take on E? What's my first step, Holly?
You need to subtract the 10.
Right, start by subtracting the 10. So if we subtract the 10, you're left with negative 2/3 P equals, what's 52 minus 10 would give you 42. Okay, what would you multiply by to get rid of this negative 2/3? Eric, what do you multiply by? Negative 3/2. That sign does go with it. Okay, so you are going to multiply by a negative 3/2. These go away, so we got P equals 42 and 2 can cross reduce to become what? 21 and 1. What's 21 multiplied by negative 3? Negative 63. So hopefully we should have gotten an answer of P equals negative 63. Does anyone get a different answer? I'll see that. Okay, let's do F as well. First thing you should do is subtract the 2. So if you subtract 2, negative and negative add together to give you negative 21 equals negative 3x. Okay, divide here. Okay, divide both sides by a negative 3. And you can divide here or multiply by the 1/3. It's the same thing. You're going to end up getting the same thing. So negative divided by negative should give you a positive 7 equals x. Now, this last one is a little bit more difficult. Okay, a little more challenging. Did we get an answer, Tony? Did you already get an answer for G?
I got 48.
You got 48. Okay, did anyone else also get 48? Couple people? Okay, who just hasn't done this one yet? Because some people, okay, there's a lot of you who haven't done that. That's okay, we'll do it together. So what do you think is my first step on equation G? Drew, what do you think is the first step?
Add 2.
Start by adding 2. Okay, if you add 2, what is negative 18 plus 2, Drew?
Negative 16.
Negative 16, right. Anytime you're adding and you have different signs, remember, same signs add and keep, different signs means subtract. Take the sign of the larger one, so negative 16. How would I get rid of this negative 3 in the denominator, Corinne? What would my next step be here? Do you have any ideas? This negative 3 is attached to the end by what operation? By add, subtract, multiply, or divide? By what? Well, what's it attached by right now? Is it attached by add, subtract, multiply, or divide? By divide. Okay, so how do you undo division? What's the opposite of dividing? Multiplication. Yeah, so what would I multiply both sides by? Negative 3. Anytime you have a negative or a positive, we're going to take it with us. So multiply both sides by negative 3. You've got this. You might not think it, but you understand, right? This goes away. N equals, what's negative 16 times negative 3?
18.
No. Positive 48. 18. Okay, negative times negative gives you a positive and 48. You're thinking just 6 times 3. Okay, so n equals positive 48. Okay, back to our notes. Okay, we're almost done, I promise. Okay, back to our notes. Let's move on to number 4. This one is one that you have not seen, or you possibly have not seen very much of before. Okay, for number 4, I would like you to solve, okay, again, we're always solving, 7 plus x over 3 equals negative 13. 7 plus x over 3 equals negative 13. Anyone think they might have an idea, about how to start this problem? This one you actually can't move the 7 yet because it does have a 3 underneath it. David, do you think you have any idea how to start this problem? Say it again? No? Think you have an idea? No, you're just stretching, Mark? No, you have no idea, or no, you're just, I don't know what you're saying. Chantel, what do you think?
No. I don't have an idea.
Nathan, what do you think? We're going to use the 3, exactly. So if I need to get rid of this 3, okay, because this is all on top, so they're not separated. If I need to get rid of this 3, how would I get rid of the 3? Multiplication, okay, so you're going to do what's called the multiplicative inverse. We've learned that. How do I get rid of the 3? If it's divided away, what do you think I'm going to have to do? Multiply it. So multiply both sides by 3. Okay, if you multiply both sides by 3, these eliminate each other out, and we got 7 plus x equals, what's negative 13 times 3? Negative 39. Now, how do I get rid of the 7? Subtract it. So subtract the 7. Negative and negative, remember, same signs, add and keep the sign. So add those together, and what do we get?
46.
Negative 46. Don't lose the negative, because that would be totally wrong. Okay, be careful to not lose your negative. And I have one more problem for us to try. Okay, last problem is number 5. On this right now, you are going to have to write a little bit of words. Okay, so you do have to write it because it's a word problem. On your homework, you're not going to have to write out the words, so you'll be okay with this one. Okay, so if I tell you that Mrs. Coon is putting a gate around a rectangular area. Mrs. Coon is putting a gate around a rectangular area. The length is 45 inches. And she has 150 inches of gate material. I would like you to solve the equation. Solve the equation. 150 equals 2w plus 90 to find the width of the area. Just a second. So, basically, let's say that I have a baby, I want to put a baby gate up around like a rectangular area. Okay, I want to keep my daughter in like a little area so she doesn't, go in the kitchen or something and get hurt. Okay, and if I know that the length of my gate, okay, I'm going to put something that's 45 inches long, and I have like 150 inches total of the gate material. I'm going to know what would be the width, okay? How big of an area am I creating here? Now, This sounds like a super crazy word problem, but really, I'm giving you the equation, okay? I am giving you this equation. So it's really not nearly as bad as it feels, okay? You're being given the equation. This is just explaining what the equation is about, okay? So here, if I want to solve for this, let's just rewrite it. So 150 equals 2w plus 90. How did they come up with this equation? Do you have any idea? Ollie?
There are 2 widths and 2 lengths.
Because there's 2 widths and 2 lengths. So if I was to draw this, okay, this is width, and I know that the length of each side is 45, right? How do you find perimeter of something? How do you find the perimeter of something? You add up all the sides. So basically this is telling you that the perimeter is equal to 150. 150 equals 2 w's, because there's w plus w, and 90, which was 45 and 45. So at some point, meaning like tomorrow, instead of giving the equation, I'm going to give you the word problem, and we're going to have to write the equation and then solve it. But for today, I'm going to give you the equations. So how would you start to solve this equation? What would be your first step? Darian, what do you think is the first step that I would use to solve this equation? Exactly. Start by subtracting the 90. Okay, so if I subtract 90 from each side, 150 minus 90 should give you 60 equals 2w. Then what would my next step be?
Divide.
Divide both sides by 2.
And you get 30.
And we should get that 30 is equal to the width. Okay, so if I was trying to figure out like how wide of an area can I make, okay, my width could be 30. And that's the answer that I'm looking for. Okay, that's the answer that I'm looking for. Does anyone, oh, I'm sorry. Let's open up our books and I want you to do one more problem. Okay, let's look at our books on page 124. And I want to look at the guided practice number 4. Okay, I want you to look at guided practice number 4. This one tells us Cassidy went to the movies with some of her friends. The tickets cost $6.50 each and they spent $17.50 on snacks. The total amount paid was $63. Solve the equation to determine how many people went to the movies. So they're telling you all about the equation, how they came up with it. But all I need you to do is solve this equation. So I want you to try to solve this equation.
What, number 8?
Number 4. We're on number 4 on the guided practice. We're on page 124. Page 124, number 4. So start by writing your equation. I'm just going to rewrite it. Jennifer, what would be the first step that I would want to take here? Sorry, you'd have to subtract 1750. Can I just subtract 1750 from 63 the way it's written?
Yeah.
What's wrong with the way this is written? You have to add in some decimal places, right? So 63 is written as dollars, so I have to put 0.00. Okay, you do have to do a little bit of borrowing and carrying here. So what's $63 minus $17.50? $45.50. Okay, so $45.50 equals $6.50 per person. If I want to figure out how many people went, what do I have to do now? Divide by $6.50. So you are going to have to do this on the side of your paper. Okay, flip it on the side and divide. $6.50 into $45.50. Before you divide with decimals, what do you first have to do? Move the decimal over. How many places should I move this? 2. So you always want to move it over the same amount that's in your outside number. So my decimal place is going to move up. Okay. How many times would 650 go into 45? 0. How about 455? 0. What do you think 650 into 4550 is going to be? We think 7. Okay. If you multiply it out, you can do this on this side. Does that work out? Yes. So that tells you what? How many people went to the movies? 7. What would happen if you got a decimal here? Would that make any sense? Would it make any sense if you got 7.2?
No.
Why would that not make sense?
Because there's no 0.2 of a person.
Because we're talking about people, exactly. Okay? Same thing as a negative. What if you got a negative answer in a word problem like this? That doesn't make any sense. Okay? You can't have like a 0.2 of a person or a half of a person or a negative person. Okay? That would be like someone paying you to go to the movies. That would be awesome, but it's not reality, so it's not going to happen. Okay, you guys need to write this down. You are going to be working on for homework tonight, starting on page 125. You are doing numbers 1 through 35 odd. 1 through 35 odd, starting on page 125. I will write it on the board just in case, but this is what we're doing today.